To find us, you must be good. To catch us, you must be fast. But to beat us, you must be kidding. Most of you must have guessed about today's arm of Indian defense that we will be talking about. A very good evening to one and all who have joined us. We are in the third day of the Defense Career Expo as a part of Yugam 2021. The Indian Air Force is the air arm of Indian Armed Forces. It ranks fourth amongst the air forces in the world. Today we'll go deep into the air arm of the Indian Defence Forces, the Indian Air Force, which has the motto Touch the Sky with Glory. We have three reputed speakers who will be inspiring you with their knowledge on the Indian Air Force. Our first session is on stealth technology by Mr. Mohith Vashisth. Stealth technology, also called low observable technology, is a subdiscipline of military warfare which has become very vital for any nation in the world. Our first speaker today is an engineering graduate in electronics and communication. He has experience of around 3.5 years in renewable energy sector. He works as a research associate in defense research and studies. Mohit is currently pursuing MA in political science and also pursuing a diploma in international affairs and diplomacy from the Indian Institute of Governance and Leadership. He works as a with researcher with Center of Security and Strategy Studies. Let's welcome Mr. Mohith Vashisth to give a talk on this curious topic of stealth technology. I welcome you, sir.
So let's start from the beginning. Good, good evening, everyone. Thanks, Arun, for passing the baton to me. First of all, I'm extremely and I want to ERAS for giving me this opportunity to express my views on a very important and strategic issue for India's defense and security. So, till a few years back, stealth technology was never an issue for India's strategic community. But with the China developing their own stealth fighter, that is J-20, a threat has been rose in India's neighborhood. Recent border clashes at Galwan Valley are a very serious testimony of the problems we are facing from the belligerent China. In this scenario, it becomes more important for India to develop its R&D infrastructure to develop its own stealth beast. A few countries, including the US and Russia, have already leveraged this technology on their fifth generation aircraft. So it is very important to understand the basics of the stealth technology along with the countermeasures that can be taken in order to hunt down these stealth fighters in case of a potential conflict with our adversaries. So, before diving deep into the domain of stealth technology, let's go through a basic introduction about this topic. So, stealth technology, which is also termed as low observable technology or LO technology, is a sub-discipline of military tactics and passive and active electronic countermeasures, which covers a range of methods used to make personal, aircrafts, ships, submarines, missiles, satellites, tanks, etc., less visible, or we can say ideally invisible to radar, infrared, sonar, and other detection methods that have been used by the various armed forces of the world. Uh, Basically, it corresponds to military camouflage for these parts of the electromagnetic spectrum, and it can be called as the multispectral camouflage. So it involves technological methods of enabling military aircraft to evade radar and other sensors in the electromagnetic spectrum deployed to detect and engage aircraft. Understanding of the topic. So the first terminology is the radar signature. So a radar signature is a set of very important information like shape, size, and speed, along with the direction of the target, which is being illuminated by the radar waves. Just like a fingerprint, it is a way to determine the type of target, as every fingerprint is different from the every other. In this way, every radar signature is different from the radar signature of another object. The second terminology or the jargon that we will be discussing about is the radar cross section or the RCS, which is also known as the electromagnetic signature of a target. So, RCS is the cross sectional area of a perfectly reflecting sphere that would produce the same strength reflection as would the object. So, radar cross section or the RCS is the measure of target's ability to reflect radar signals in the direction of the radar receiver. It is a measure of how detectable an object is by the radar. In simpler words, we can say that a larger RCS indicates that an object is more easily detected. So, strategic advantages. So, the bearer of uh, has the control over the air superiority domain. So, stealth technology in aircraft decreases the RCS of the fighter jets that we have already understood. So, when the RCS of an aircraft decreases, its stealth automatically increases, and this allows the stealth fighter to conduct some very covert, tactical, and strategic operations that too very deep in the enemy area, which the conventional airplanes could not be able to implement because of their more RCS and they are more visible on the radars. So this invisibility imparts them a unique advantage that they can enter the enemy area undetected and perform these covert operations very effectively and efficiently. And by the time the conventional or the legacy radars identify these stealthy machines, no time is left to deploy the air defense systems. This technology has been used in the fifth generation aircrafts by many countries like the US, Russia, and China. Many other countries are in various phases of development of these aircrafts. We'll be looking at some stealth aircrafts which have been developed by the US, Russia, and China. So first of them is the F-117, which was built and developed by the Lockheed Martin, which is a the second is the Bomber 2 or the B-2 Spirit, which was not basically a fighter jet, it was a bomber which used to take part in bombs over the desired area or the target. Uh, it is also being operated by the US Armed Forces. Uh, Third one in the list is the F-22 Raptor. F-22 Raptor is one amongst the most advanced aircraft that has ever been built by any nation. It has a lot of features, including the ISA radars and stealth technology with the coating of radar absorbent material. So it is very advanced if we compare it with the other fourth or 4.5 generation aircrafts of the other nations. This is F-35 Lightning II, and we can say that it is the most advanced aircraft in the world right now. It has the most cutting edge and the futuristic technologies. It is imbibed with a lot of arrays and sensors which can give the real time actual information to the pilot about what is happening in the aerial domain. This is the real concern for India. That is the Chengdu J-20, which has been built by the China and it is already commissioned a few years back. And the associated risk with Chengdu J-20 is that it can enter the Indian airspace undetected, which is a serious problem for the Indian armed forces. And we'll be discussing that how can we tackle these stealth aircraft in the coming part of the presentation. Now, this is the last photo that I'll be showing to you. This is Sukhoi 57 manufactured by the Russia, and it is also the fifth generation aircraft. It is equipped with various stealth level technology along with some very advanced passive radars. So now we are going to discuss about the techniques that are being used to decrease the RCS or the radio cross section of the aircraft and increase the accuracy of the radar images. The method is the shaping or the geometry of the aircraft. So, geometry is one of the most important factors affecting the RCS or the shape of the target and not its size. In order to reduce the RCS, the surfaces and edges should be oriented in such a way so as to reflect the radar energy away from an expected radar antenna and not back to it. A design feature which is known as planform alignment is used in decreasing the RCS of the stealth fighters. It involves using a small number of surface orientations in the shape of the aircraft structure. For example, in F-22 Raptor, see this is the cross section of F-22 Raptor. So the leading edges of the wing and tail surfaces. If you look at the wings and the tail of F-22, one might find that the leading edges of both the surfaces are at the same angle. And careful inspection will show that many small structures, such as the air intake bypass doors and the air refueling aperture, also have the same angles. This technique, or the effect of the planform alignment, is to return the radar signature in a very specific direction away from the radar emitter, rather than returning a diffused signature. So the second technique or the method which is used to increase the stealth of an aircraft is the usage of the propulsion subsystem shaping. So in PSSS, or the propulsion subsystem shaping, nodules in aircraft jet engines, which helps in manipulating the thrust output of the engine, through which the speed and altitude of aircraft can be controlled. Such nozzles produce a much lower RCS due to the fact that these are less complex and mechanically simpler and less massive with no moving parts. These are likely to find usage in the sixth generation fighter aircraft also. So the third technique, which is used widely by all the nations which are operating the stealth aircraft, is the use of radar absorbent materials, or the RAM. So this we have to understand that the spatial shaping is the most important contemporary method to reduce the RCS of an aircraft, and it is responsible for the main part of the RCS reduction. The second technique that we are talking about is the use of spatial alignment. Part of the received radar energy RAM neither absorb all received radar energy nor are efficient at all frequency bands. It is considered as a supplementary approach which helps in reducing the RCS which cannot be applied. One such type of paint which consists of depositing pyramid-like colonies on the reflecting surface with the gaps filled with the iron-based RAM. So this pyramidal structure reflects the incident radar energy, which is bound to reflect from the aircraft's structure in the maze of the radar absorbent material, which in turn reduces the resultant RCS by many degrees of magnitude. So the fourth technique, which was first used by the Russia, is the plasma use of plasma to increase the stealth of an aircraft. In such types of systems, superheated ionized gas is used to decrease the RCS of the aircraft. When radar waves are received, absorbed, and scattered by a plasma capable of absorbing and scattering a wide range of radar frequencies, angles, polarizations, and power densities, rather than actively sending threat signatures directly back to the transmitter, the plasma is more likely to scatter the radar energy. In 2002, the Russians tested a plasma stealth device on board and Sukhoi 27, and the RCS of the aircraft was thus reduced by a factor of 100 magnitude. So the using of ablative paints has found a way in decreasing the st- uh, decreasing the RCS of an aircraft from past many decades. As the name suggests, the paint does not absorb the radiation, but it simply conducts it over the skin, aircraft skin, tending to cool down any electromagnetic hotspots on the airframe. These paints were initially very heavy. In the very beginning, these paints were very heavy, but with technological advancements, their weight has been reduced considerably, which allows more areas to be covered. Thus, this in turn would reduce the radar signature even more. A commonly used material is also known as iron ball paint. It consists of small micro iron balls, which, when painted over the structure of the aircraft, it covers the structure with micro iron balls. And when the radar energy hit the structure, it simply conducts the energy over the skin. So another technology which can be used in the visual stealth domain is the smart skin technology. So in the field of visual stealth, while various types of painting strategies are being used, but the cutting edge research is the chameleon or the smart skin technology, which would enable an aircraft to change its appearance to mimic its background. Uh, Another technology which is being used by almost all the aircrafts is the use of fly-by-wire systems. So fly-by-wire systems are semi-automatic, computer-regulated aircraft flight control systems that replace mechanical flight controls with an electronic interface. So computers and advanced electronics make a great contribution to aircraft safety, ensuring manageable such as the fins and the rudders to be reduced in size or even eliminated, as we had we had seen in the B2 Spirit. Well, as we discussed about the advantages, strategic advantages of the stealth technology, this presentation and this webinar will not be complete if we do not talk about the limitations of the stealth technology. So moving forward with this topic, we would like to talk about the instability of the design and the aerodynamic limitations which stealth technology poses. So stealth aircraft are designed with the focus on minimal RCS rather than the aerodynamic performance. Generally, they tend to be aerodynamically unstable and require constant flight correction from a fly-by-wire flight system to maintain a controlled flight. However, flying wing designs, as was used in the B2, uh, the Bomber 2 series of the US Armed Forces, so the flying wing design allows the aircraft to be more stable as compared to the contemporary classical designs. A flying wing is a tailless, fixed-wing aircraft that has no definite fuselage, with its payload, fuel, and equipment housed inside the main wing structure. Example of the flying wing aircraft is the Bomber 2 Spirit. So aerodynamic features of the aircraft are sacrificed on the altar of stealth in order to reduce its RCS. This leads to a limited maneuverability also, which plays a important role during the dogfights. The second imitation of the stealth technology is the electromagnetic emission. Due to the amount of electronic equipment used inside stealth aircraft, they are vulnerable of the electromagnetic emissions that they emit during their operation. And these electromagnetic emissions can be used to detect and track down the stealth aircraft, which makes them uh, third limitation of the stealth technology. Stealth aircraft are still vulnerable to detection while and immediately after using their weaponry. Since stealth payload is not yet generally available and ordnance mount points offers a significant radar return, stealth aircraft carry all armaments internally in their ammunition bays. As soon as weapons bay doors are opened, the plane's RCS will be increased exponentially, and even older generation radar systems will be able to locate the stealth aircraft. While the aircraft will reacquire its stealth as soon as the bay doors are closed, a fast response defensive weapon system has a short opportunity to engage the aircraft. Till now, only one aircraft has been shot down, and this happened due to the above vulnerability we just talked about. So, an F-11 during a mission Yugoslavia on 27th March 1999, during the Operation Allied Force, the Army had detected the aircraft on radar. As soon as the pilot opened its ammunition bay doors to attack, which raised its radar signature. So, the fourth limitation of imbibing stealth technology into a fighter aircraft is the reduced payload of the fighter jet. Fully stealth aircraft carry all fuel and armament internally, which limits its payload capacity. If we with a non-stealth attack aircraft, we will find that the F-117 carries only the deployment of additional aircraft to engage targets that would normally require a single non-stealth attack aircraft. So, fifth imitation of the stealth technology can be imparted to the usage of radar absorbent material, which make their skin very sensitive and they are vulnerable to erosion and corrosion during sorties and other operations. The sixth limitation of using stealth technology is obviously the cost of operations. Due to the use of highly sophisticated and cutting edge technology, stealth aircraft are typically more expensive to develop, manufacture, and operate as compared to their conventional counterparts. With the arrival of stealth technology, came the counter stealth technology. Many contemporary technology can be tweaked a bit in order to make them efficient in the counter stealth domain. So one of such technology is the usage of longer wavelength or the shorter or low frequency radars. So the Russians are in the forefront, followed by the Americans and Israelis, and the French are working on radar frequency bands that are optimized to detect the stealth targets. Experts have realized that lower frequency bands make much better counter stealth radars than the higher frequency bands, which are conventionally most popular radar bands for the military applications. For threats that remain on the other side of the hill and uses these hills or mountains as a barrier to hide themselves in the plain sight, these radars can be used uh, as the over the horizon or the OTH radars. As we know that this capability of hiding behind the hills and mountains is well existent with our immediate neighbors, so it will be a very good supplement uh, to our already established radar infrastructure. Such types of radars are used to detect the target, which uses the hills or mountains to camouflage themselves. OTH or the over the horizon radars launch their waves at a higher elevations over the hill and thus escaping them out of the atmosphere, which finally hits the ionosphere from where these get reflected and thus cover the area beyond the obstacles such as the hills and the mountains. The second technology, which is quite promising in the field of counter stealth, is the LIDAR or the light detection and ranging technology. The principal working of these types of LIDARs is the use of laser technology. While most of the stealthy platforms are either designed to evade, absorb, or deflect the incident radar energy lying in the electromagnetic radio frequency range, but these are not so optimized for the light waves lying in the laser region. Typically, laser waves have extremely short wavelengths. At such low wavelengths and hence very high frequencies, or extremely high frequencies, the typical stealthy aerial targets give away their location owing to higher reflectivity of this band of electromagnetic waves. The second technology which can be used and is already being used in the counter stealth domain is the multi-band 3D radar. This is a recent technology uh, developed by Russia in late 2008. This radar system is a package of 3 to 4 discrete radars and a single processing and command post. Each of these radars operates on different frequency bands. The Nebo M, which has a Russian origin, is a new development based upon the Nebo family of very high frequency 2D and 3D mobile air surveillance radars featuring active electronically scanned array or the ISA technology. Besides, the Nebo M includes the radars operating in the L band and X band. The very high frequency band element of the system provides sector search and track functions of the low RCS targets, while the X band and the L band elements provide a nice tracking capability. Stealth technologies pose no problem for these new types of radars, and the Nebo M consists of three vehicles carrying a giant swimming pool sized antenna. One antenna is comparatively smaller and a command post module. And together they can scan airspace at a range of around 1800 kilometer and an altitude of around 1200 kilometer. The Nebo M takes just 15 minutes to deploy and it's mobility, enables positioning in any required direction. It also has strong jamming protection and works even if its radar system gets knocked out. Multiple input, multiple output, or the MIMO radar also offers quite an impressive level of protection against the stealth targets. It basically uses multiple transmitting antennas and multiple receiving antennas, which are placed at a small distance from each other. And MIMO radar employs multiple trans- transmit waveforms and has the ability to jointly process signals received at multiple antennas. Now, all the transmitting antennas use different frequency bands in order to get a very fine radar signature of the stealth target. The waves which get reflected from the target can be read by the all the receiving antennas, thus giving an improved spatial resolution of the desired target. Passive anti-stealth measures o- offer a good efficiency against the stealth targets. Such systems typically uses either low frequency broadcast, TV and FM radios, or so systems do not use reflected energy and only support measured systems. Lockheed Martin Silent Sentry was the earliest example of this technology. Uh, Other well-known examples of passive radars comprise the Czech Emara or the Vera system and the Ukrainian Kolchuga system. So the first picture is of the Czechoslovakian Tamara system, and the other one is the Ukrainian Kolchuga system, which are both the types of passive anti-stealth measures. A Cascadian, which is part of the vast European Aeronautic Defence and Space Company, has developed a type of passive radar which it claims can uh, find the stealth aircrafts. According to a report in Defense News, the Chinese are also claiming that their DWL-002 passive detection radar system will make the stealth features of the forefront runners like the F-22 and the F-35 obsolete. Going a step further, open source talks about the Chinese going in for an integrated air defense system hooked to a central information processing center, which features multiple radars with high altitude unmanned aerial vehicles along with the satellite spatial Tracking. Technology Yeah, so cell phone radar basically operates in two domains. So first one is when target enters the detection range, the cell phone's reflected signals are detected by the cell phone radars. The collected data are then sent back in real time to a central control system via a communication network, and fusion takes place, and this passive system is able to determine the position and the speed of the target objective. So basically this technology can be utilized by exploiting already installed infrastructure of the cell phone towers, which continuously emits microwave ranges. So the next technology is about the quantum radar. So quantum radar is a hypothetical remote sensing method which is based on quantum entanglement. One possible implementation of such technology has been developed and patented by the defense contractor Lockheed Martin. It intends to develop a radar system which provides a better resolution and higher detail than classical radar can provide. The technology is hoped to work by using photon entanglement to allow several entangled photons to function as if a shorter wavelength was used to allow detection of small details while having an overall longer group of wavelengths that allows long distance transmission. Infrared search and track systems basically employs various electro-optic sensors in order to detect and track the stealth or the non-stealth aircrafts. And many researchers and analysts says that infrared search and track system or the IRSTS can be deployed against both the stealth and the non-stealth aircraft because any aircraft surface heats up due to the air friction, and this heat can be used to trace these strategic machines. The latest version of the MiG-29, that is the MiG-35, is equipped with a new optical locator system that includes more advanced IRST capabilities. Along with it, French Rafale, which India bought from the France recently, uh, and a combined effort of England, Germany, Italy, and Spain, that is the Eurofighter, also make use extensive use of these IRSTs. Now, having discussed about all the basic things about the stealth technologies, their limitations, their strategic advantages, about the counter stealth technologies, and how can we use these technologies in hunting down these strategic aircrafts. There is always a stealth and counter stealth debate duel among the analysts that which one is better. So this debate, in this debate, we'll talk about which technology is better, whether India can go for developing its own stealth technology or it should go for it developing the anti-stealth imperative. So first of all, there is a very huge economics gap between the stealth and counter-stealth technologies. Well, when we'll talk about acquiring stealth technology, it is very expensive as compared to the counter stealth technology. So acquiring or developing counter stealth technology is quite cheaper as compared to the stealth technology. So counter stealth technology clearly emerged as a winner in this domain. The second thing which comes during the stealth and counter stealth debate is the vulnerabilities of the stealth aircraft. Having a stealth aircraft does not make you godly. It isn't like the stealth aircraft cannot be detected and targeted in any condition. It is quite evident from the fact that the American F-117, which was a technological wonder and a masterpiece of its time, was downed by a third world country, that is Serbia. So basically, what Serbia upgraded its 1960s built Soviet based Neva missile system that was basically a surface to air missile battery to detect and attack the F-117. And it did so when F-117 opened its ammunition bay to attack. Those were the 17 seconds on which it appeared on the radar, and the Serbian military attacked with it with almost obsolete Soviet-based Neva missile system and downed it. It proves the fact that all stealth aircrafts are vulnerable to existing and futuristic counter-stealth technologies, which are comparatively much cheaper than the corresponding stealth technologies. Third issue, which comes with having or developing stealth technology, is the ignition of a new arm race, and it comes with several geopolitical implications also. If we talk about the diplomatic front, then developing counter stealth technology carries less diplomatic baggage. As supposedly, if one country is developing anti stealth technology, that it can easily say that it is doing so in order to defend itself from the stealth aircraft. But when the same country is developing a stealth aircraft, it cannot say that it is for the defensive purposes, because the stealth technology can be used for aggressive purposes since its raison d'etre is to penetrate enemy defenses. Thus, committing to counter stealth technology development runs less risk of antagonizing neighbors than developing stealth technology. One another important thing about uh, developing counter stealth technology in as compared to the stealth technology is the confidentiality issue. When a country is developing its own stealth technology, then that project is very big and it is quite a long project. So developing stealth aircrafts cannot be done in secrecy, while developing countermeasures against the stealth technology can be done secretly, and the adversary with the stealth technology can be detected by using it at the right time. As we know that China has uh, developed its own fifth generation stealth fighter, that is J-20. So how can we put a way forward from India's perspective? There are many things that India can do in order to counter the uh, stealth aircraft of China, and it can do so by various methods. The later version, surveillance, tactical, and missile guided radars with the Indian Armed Forces and basically with the Indian Army, that is the Central Acquisition Radar and the Tactical Controlled Radar, low level lightweight radar, and more have significant technological ability to detect the stealth targets. These can be tweaked in order to detect and target the stealth aircraft. Several Soviet era old surface to air missile systems are still being used by the Army Air Defense, like the P series of radars, which I have listed here. That is the P12, PRV-11, PRV-16, P15, and P18. Uh, some of these radars operates on the low band, very high frequency. Even if the main equipment gets obsolete or are no more in a working condition, that instead of de-inducting it, the radars of these system can be used in order to detect and isolate the stealth targets. Now, DRDO and Bharat Electronics Limited has already worked upon a large number of radars, and it uh, has given India, these developments have given India a self-sufficiency in the radar domain, and most of the radars are produced indigenously by India. So, what BEL and DRDO can do via a joint venture with the public-private partnership, they can develop a large number of radar technologies to detect and target the stealth aircrafts, which will automatically give a tactical and strategic advantage to the Indian forces during a potential conflict. And the most important, India is planning to develop its own fifth generation stealth fighter, which will impart India direct attack capability, and it will also give boost to the capability of the Indian Air Force to enter the enemy area and conduct the covert and strategic operations with a full efficiency. So this is the prospected fifth generation stealth aircraft of India, which has been named as the Advanced Medium Combat Aircraft. With this, the PPT is completed, and if there are any questions or some comments, people may ask. Thank you.
So, since we have some technical issues, the webinar will continue soon. Stay connected.
So, Akansha Tiwari has asked that how long will it take for India to manufacture something like F-22 Raptor or the Sukhoi 57? Well, this question is quite open-ended and it is very difficult to answer, as developing an aircraft like F-22 and the Sukhoi 57 that you are talking about will generally take 10 to 12 years to develop and manufacture the basic variant of the aircraft. But as there are several problems with the defense industry, whether it is the public uh, defense undertakings or the private industry. So it totally depends upon the defense manufacturing environment of the country, that how much time will India take to manufacture these stealthy birds. Uh, as per me, both the stealth, speed, and maneuverability has their own space. See, if a pilot is flying a stealth aircraft, then he must be well equipped with the actual happenings or the actual scene of the aerial domain with the advanced aero-optics sensor, electro-optic sensors, and other active and passive radars. The pilot will be having all the information of the aerial domain. So flying a stealth aircraft is very different from a non-stealth aircraft. Non-stealth aircraft exactly has high speed and high maneuverability, but when you have all the real-time information processed by the computer about all the happenings or the threats which are approaching you, then obviously you are in a better condition to operate. And at that particular time, the speed or the lack of maneuverability or the lack of speed obviously get patronized by the stealth. So stealth does not only apply to aerial vehicles, it can be applied to land and underwater vehicles. In fact, many land vehicles are already deploying some stealth techniques in order to camouflage themselves from several electromagnetic radiations. And in case of underwater vehicles like the submarines, the stealth means not evading the radar but the sonar. Actually, in water, the speed of sound increases as compared to the air. So, yeah, it can be applied to aerial vehicles as well as land and underwater vehicles. Well, Rafale is a 4.5 generation aircraft, and although its performance is very effective as compared to other aircrafts of this generation, but if we talk about the Chengdu J20, that then it is having some very advanced feature along with the stealth capabilities that I am very sad to say that I think will overpower the Rafale.
Light on stealth technology, sir. I hope that the viewers would have gained a greater understanding about radars, how stealth significantly affects the visibility of an aircraft, and also about its limitations. You also gave many examples which are very interesting to hear, sir. Again, thank you for joining us and sharing your valuable knowledge about stealth technology, sir. Sir, can you hear me now, sir?
Yeah, I can hear you now.
Okay, sir. So thank you for giving a great insight on stealth technology, sir. I hope that the viewers would have gained a greater understanding about radars, how stealth significantly affects the visibility of an aircraft, and also about its limitations. You also gave many examples which are very interesting, sir. Again, thank you for joining us and sharing your valuable knowledge about stealth technology, sir.
Yeah, it was my honor to be here. Uh, Thanks for everything. It was so
Thank you,
nice
sir.
to be here. Yeah. Thank you, Jai Hind.
Jain, sir.